All right, more chords and arcs today. This is 12.2b. And there are three theorems again. Again, very closely linked to each other, very circular. One affects the other, which affects the other, which goes back to the one we started with. So here it is, these three theorems. We're going to start here with theorem 12.8. Theorem 12.8 says, in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc, okay? So basically what we're saying is if we know that this is a diameter, in other words, it went through the center, if we know it's perpendicular to this chord, then because it's perpendicular to the chord, it will always make these two congruent and these two congruent, okay? So the chord gets bisected and the arc gets bisected. Okay, that's theorem 12.8. Second one, theorem 12.9. This one says, in a circle, if a diameter bisects a chord, then it is perpendicular to the chord. Okay, so now they're telling us it is a diameter, so we know it goes through the center, okay, and it is bisecting the chord. Okay, if we know those things, then what we can conclude, is that this will be perpendicular. Okay, so very similar to the last one, right? Just looking at it with two different pieces of information. Pretty much all three of these have three pieces of information, two that you know, and then one that you know because you know the other two already. So let's look at this third one. My guess is you can probably tell me the missing piece at this point. This one says, in a circle, the perpendicular bisector of the chord contains the, and this is center of the circle. So basically what this is saying is if it is perpendicular and cutting the chord in half, then even though they don't give us that point, we know that the center of the circle has to go through there, okay? So you have a center, you have a perpendicular, and you have bisecting going on. If you know any two are true, you know the third one is true also, okay? So we're going to look at that, and we're going to do some solving here. So this one says find x to the nearest tenth. And what we know in this, and it's not easy to see on this just because of the way it's drawn, but we know this is the center of the circle, okay? So if that's the center and it's perpendicular, the theorem says that this then, because you could draw a diameter all the way through that, we're not going to, but that will bisect the chord that it goes through. So in other words, these two parts are going to be equal. Well, if the whole thing is 12, then that makes this 6. And if that is 6, now we're looking at a right triangle right here where we know two of the sides. So what we're going to do is say Pythagorean theorem, 5 squared plus 6 squared has to equal x squared. Okay, this comes out to 61 equal to x squared. So we just need to take the square root of that, and we're going to round this to the nearest tenth, it said. So x is going to be approximately 7.8 units long. Okay, that's the first one. The second one, if you look here, notice we have a center. You know what? Shoot. I didn't want to give you this, but I can't get rid of it. Normally right here, you guys, you won't have this drawn in for you. What that means is you have to figure out that if I have a radius right here and we move it over to here, I just made a triangle, okay? I know this piece is x, I know this piece is 5, and because it's cutting this into two equal parts, I know this is perpendicular. So now we know we have a right triangle, but you need to know, like, hey, if this is a radius of 9, I can move that radius anywhere, and it's still 9. So if I need to move it to make a triangle here, then my triangle, I can, because it's a right triangle, do Pythagorean theorem with that. So this would be x squared plus 5 squared equals 9 squared. And then we'll solve from there. If we take 5 squared away, so take 25 away from 81, we get 56. So we would get x squared equals 56, and then we take the square root of that. So x would be approximately, if we round here to the nearest tenth, it's about 7.5. Okay. All right, next one. Here's an example of one of those. So if I have x here, okay, and again, this is the center. It's hard to draw a good dot in the middle, but you would know this is the center, okay? Because these two parts are equal, it's got to be perpendicular. So I know I have a right angle here. We're looking for what is the distance to that chord, finding x. This 15 is a radius. So if that's a radius, I can put a radius anywhere. I can put it right here. And now I have a right triangle, and I know two of the sides because I know the radius is 15. So we're looking at this right triangle, 11x and 15, and we're just doing Pythagorean theorem. You're going to notice you're doing a ton of Pythagorean theorem today. So hopefully that's very simple for you because you guys have done it a lot this year. But we're doing x squared plus 11 squared equals 15 squared. Make sure your hypotenuse is always the standalone. So we're going to take away 11 squared, or take away 121. Don't subtract this right now. Don't go 15 minus 11 is 4 and then square that. That doesn't work. You have to go 15 squared minus 11 squared. Okay. When you do that, you get 104. Okay. And then we're going to take the square root of that, and x comes out to approximately 10.2. Okay. All right, last one for today. Knowing what we know, again, this is the center, okay? We got to know that. So in the circle, we have a distance of 4 here. We have a distance of 6.8 for our radius, and we know this is perpendicular. So if we know that's perpendicular, then we know that these two pieces are the same. Well, if we look at this triangle, we'll do it in green here. This triangle is a right triangle where we know two of the sides. So if I draw that triangle again, let's say this is 4, this is 6.8. We'll call this y because it's just half of x. You could call it half of x, but so many people do the math wrong when they do that. So I just usually give it a different variable. So that when I say y squared plus 4 squared equals 6.8 squared, and I solve for y, then I know I just need to double it to find x. I'll show you the other way, but I'll show you where a lot of people make mistakes. So this is y squared equals, we're going to take away 4 squared from both sides. So 6.8 squared minus 4 squared, you get y squared equals 30.24. Okay, so we square root that, and we get y is approximately, now here's where you do need to be careful. Because we're rounding and then finding something else, don't call this to the nearest tenth yet. I would call this 5.499, or just leave it in your calculator as you see it is fine. X is double that, so 2 times that 5.499, and now you can multiply to the nearest tenth. So, oh, and this one's fancy. Here's what you get. 10.998, and it keeps going. This answer, if you're rounding to the nearest tenth, you're looking here. Well, this 9 bumps that up, which bumps that up. So this is actually 11.0 units long. Okay. Don't call it 11. 11 is not nearest 10th. 11.0 would be nearest 10th. Okay, for those of you that are good with that, you can turn me off right now. But for those of you that like to call this 1/2 of x, I'm going to show you how you would have to do that to make sure you do it correctly. So if you want to stick around and hear that, go for it. If you're good, get to work, turn me off. Okay, so if I call this 1/2 of x, then I need to say 1/2 of x squared plus 4 squared equals 6.8 squared, okay? When you square 1/2 of x, you're squaring 1/2, which is 1/4. So you have 1/4 x squared plus 16 equals 6.8 squared, 46.24. So if I take 16 away from that, I get 1/4 x squared equals 30.24. Okay, that means from here, I need to multiply by 4 to get the 1/4 out of here. So times 4 gives you this number, x squared equals 120.96. And when you square root that, take the square root of your answer, you get x is 10.998, just like we did before. So x is 11.0 to the nearest 10th. But I will tell you right now, so many people call this 1/2 x squared and then they multiply by 2 instead of multiplying by 4 because they forget to square the 1/2. So if you're gonna do this is 1/2 x, make sure you square the 1/2 also, okay? Otherwise, just do it this way. Call that piece of it a different amount and then double it because we know these two pieces are the same. Okay? That's it for 12.2b.